Now, before we get into visual testing, I want us to play a little game of Who Done It.
Clearly, somebody in this room murdered Lord Smythe, who, at precisely 3:34 this afternoon, was brutally bludgeoned to death with a blunt instrument. I want each of you to tell me your whereabouts at precisely the time that this dastardly deed took place.
I was polishing the brass in the master bedroom.
I was buttering his lordship's scones below stairs, sir.
Why, I was planting my petunias in the potting shed.
Constable, arrest Lady Smythe.
But how did you know?
Madam, as any horticulturist will tell you, one does not plant petunias until May is out. Take her away.
That's right, madam.
It's just a matter of observation. The real question is, how observant were you?
Action.
Clearly, somebody in this room murdered Lord Smythe, who, at precisely 3:34 this afternoon, was brutally bludgeoned to death with a blunt instrument. I want each of you to tell me your whereabouts at precisely the time that this dastardly deed took place.
I was polishing the brass in the master bedroom.
I was buttering his lordship's scones below stairs, sir.
Why, I was planting my petunias in the potting shed.
Constable, arrest Lady Smythe.
So did you notice any of the changes? Or maybe just one, the biggest one, where the dead man got up and walked away? Probably not, because we all suffer from what's called unintentional blindness. Unintentional blindness is where you miss things that are unexpected that enter your viewport because you're so focused on a specific task at hand. And this is especially true when we talk about testing our code. We're so focused on whatever feature that we're developing that we miss anything else that might be going on in the application. But how do we typically solve for this? Well, we automate the test, right? Because if we automate the test, then we can be sure that the same steps will be followed every time, the same verifications will be made every time, and we won't miss anything. But what if I told you that when you automate your test, you're actually scripting in intentional blindness? What? Yeah, because when you use traditional testing tools, they query the DOM, the document object model, in order to determine what's there or not, right? So for example, if you asked, is this text present? It's not going to look on the screen. It's going to look in the DOM and see if that text is in the DOM. If so, it tells you, yes, it's there. But what if it was covered by some other element and therefore your users can't see it? What if it was the same color as the background? So again, they can't see it. What if it was bleeding off the edge of the page? What if? Lots of things can go wrong here. And these might sound like edge cases, but let me tell you, I see these visual bugs everywhere, all the time, in all sorts of applications. So it's not just a nice to have. Let me show you a few apps. This is Cineworld, second largest cinema in the planet, right? And they had visual bugs on the page that asks you if you want to store your credit card information. So we look at this and the labels are not aligned with the radio buttons and it looks kind of comical. But let me ask you this question. Would you store your credit card information on this page? I wouldn't. And I doubt you would either. In fact, Kim tweeted about this. She was so annoyed because what this implies is that they didn't do any testing. And if they missed this on the surface, who knows what's going on the back end, right? I'm not storing my credit card information there. Obviously, they didn't test this. But I have a theory. I think they did test it. In fact, I think that they automated the test. And if you automate this test, what happens? You query the DOM, the label is present, the radio buttons are present, the test passes. And this is how those visual bugs get to production. Here's another one with OpenTable. OpenTable is an application where you go to make restaurant reservations. I used to live in North Carolina, known for barbecue, and I went back to visit and I wanted to go to my favorite barbecue place, The Pit, and catch up with some old friends. So I was going to make a reservation for 7 people and they presented me with the times. I chose the 7 p.m. slot. When I did, a modal appeared. And it took me a minute to figure out, what am I even supposed to do here? Because there, is nothing in the center. But when I looked in the upper right corner, I noticed, oh, there's 2 select buttons there. But what am I selecting? There's no text here. These buttons aren't aligned. Clearly something is wrong here. So I did what any of you would do. I opened Chrome DevTools and I began to dig around in the DOM to figure out, what are these buttons? And when I did, I noticed that the labels were there. They were just as far away from those buttons as possible. So me being the engineer that I am, I completed my reservation because I'm also a foodie, right? But I couldn't help but think about all of the other customers that aren't engineers, that don't know about Google and Chrome DevTools, and they aren't going to dig around the DOM to complete a reservation. No, most people are going to exit out of this. How much business is lost because of this visual bug? And functionally, everything works, right? Think about if this test were automated. The scripts, they would be able to interact with those buttons, no problem. Totally missing the fact that the screen is obscure. All right. These are not one-offs. This happens to your favorite tech companies as well. Look, it happens to Amazon. Mobile view here. Let me tell you, visual bugs love mobile screen sizes. That's where they like to hang out. So here, someone is not only trying to buy a product, but they're trying to increase the quantity, meaning multiply the amount of money that they're going to spend, and yet they're faced with this visual bug. If they wanted to buy anything more than 2, they're out of luck. Facebook. Look at the text there. This is their marketplace. This doesn't make me want to shop. I can't read the text. It's overlaid on the images. Just like in the other example, if we query this stuff in the DOM asking, is this text present? We would get a thumbs up, not knowing that it doesn't look good at all. Instagram. Is this text present? Is this text present? Is this text present? Yes, yes, yes. The test passed. This is sponsored content, meaning someone paid Instagram for premium placement of their ad, and this is what was shown. Totally missed by our test. Twitter. The tweets are overlapping. What do you do when you see this? You close the app, right? Even Google. And this one isn't that bad, but it is a point of purchase, right? Which means they're going to want to fix it. And some high salaried engineer has to stop innovating new features to track something like this down. Fortunately, we don't have to live like this, people. The visual validation can be automated as well. So what is visual validation? It's where you take a screenshot of your application in the state that you like it in. And then for every regression run, another screenshot is taken and it compares those 2 images. If there are any differences, it lets you know. Now, be careful with visual testing tools. Lots of them are using dated technology, right? So visual testing is not new to the space. In fact, as an industry, we were using like pixel to pixel to compare the images. And what was discovered is it's highly flaky. It doesn't work very well. It's not intended for testing software. Let me show you a couple examples. So in this first image, this is my application when it's in its perfect state. And the bottom one is a regression run. This test fails. Why? Who can see why? If you said because that Google search button is bolded in the second example, you're correct. what happened there is the mouse happened to be hovering over that button, and that's the hover effect. But this is an automated test. We can't necessarily control where the mouse is without, writing a bunch of tedious code that we don't want to. You don't want this stopping your build, right? Here's another one. Who can see why this one failed? Yep, that cursor behind the word bad. It's solid. Well, cursors blink. Yes. So if it happens to take the screenshot when the cursor is solid and then it takes it when it's not, this would fail. So again, pixel to pixel is really sensitive, and that's not what you want gating your deployments. Fortunately, Applitools has come up with a much more sophisticated approach using machine learning to be able to detect the differences between the images, right? So it mimics the human brain and eye, only picks out the things that we care about or would notice as a human being. So here's another game. You all don't get to play because you let the dead man walk in the other one, but it's a spot the difference game. And I ran spot the difference through a pixel to pixel comparison. And then I ran it through Applitools' eyes, API is what it's called. And when I ran it through pixel to pixel, notice here, everything is highlighted. Like I told you, it's highly sensitive. Every little white space shift is detected. This doesn't tell me what I need. Versus when I ran it through the Applitools eyes API, it found the things that I would have picked out as a human being. Okay, so enough of talking. Let's add this to an existing code base. So first, let's look at the application under test. Basic single page app, 8 of my favorite books on testing. And the way that this works is you can filter the books by title. Full title or partial title, right? So I enter the word test in the filter and notice the 5 books that have test in the title are the ones that are visible. Now here's the test for that, okay? So I'm going to walk you through it. We have a query. We're going to enter the word test. Here are the expected books. Put those in an array. I'm going to actually invoke that that's filter, that's search. And then I have 2 validations on line 10 and 11. One, make sure that only the books that I'm expecting come back as far as quantity. And then I loop through that array and make sure that those are the titles that are there. Okay, so I feel good with this test. It's a pretty good test, right? All right, but now I want to get my CSS on and I want to spice the app up a bit, maybe add a little bouncy effect or something. So I add line 6 here and I check it in because I have tests. And when I have tests, I can do whatever I want. So I check this in. Again, here is the test for that. This is the test I'm banking on to catch any goof ups I make, right? And this is what the application actually looked like with that CSS. With that one line, I literally flipped this application on its head. But I have tests, right? So I run the test with Cypress and it's green. Even though my application is flipped upside down. Again, this is why we need the visual testing, right? This is how we test our CSS, make sure that besides the functional goof ups, that we're not making visual ones as well. All right. So we're going to update that test. We're going to clear out the assertions. I don't need that array anymore. I've simplified this. I just need to do visual testing because when I add eyes to my test, I get a lot more coverage with a lot less code. All right. So line 2, I say search for test. And then I'm going to use the Applitools API. Now it integrates very nicely with Cypress as well as any other test automation tool that you want to use, any language as well. All right. So it's like poetry, right? We say, open your eyes. That's the first command. It's 3 easy commands. Open your eyes, right? Give it the name of the application. Next line 4, this is the magic. We say, eyes check window. So this is where it takes the screenshot. It's going to send that screenshot out to the Applitools cloud and store it there. So you don't have to worry about the storage or anything fancy to take the screenshot. That one line of code literally is it. We're done. Close your eyes. Okay. So when we run the visual test, notice now the test fails because it's not looking in the DOM. It's looking on the surface and it sees, girl, you flipped those books on its head, and it fails the test as I need it to do. All right. Now, look at this. This is with those 3 lines. I'm not only testing the books, I'm really testing this entire page. So it flagged what was different. That's what's in pink. But that filter button, that's part of the image. The title is part of the image. So in everything here, the whole page is part of this image, meaning if a pink elephant flew across this screen, it would catch that too, even though I'm not explicitly looking for that. All right, that's great. But also sometimes there may be, active development going on the page, or, we want to scope our testing down. You can do this as well. Very flexible API. So I'm going to change that test now. I only care about that one book. I'm looking for agile testing specifically. I just want to get that one book. And I can do that by calling the check window, but pass in, hey, I want to scope it down to a specific region. And here's my CSS selector for the region that I want to scope down to. All right. So when we do that, then notice the screenshot is only of the book and not the entire page. So this is great for when we want to scope our test down. However, there are cons here as well. You have to really think about this. When we use machine learning, sometimes we expect it to do a lot of the processing for us, but we're the brains behind the operation. And what we actually did here was reintroduce unintentional blindness. For example, let's say filter is broken. I enter test in that filter and nothing goes away because filter doesn't work. Would our scope down test pass or fail? If you said that it would pass, you are correct, because what it's going to do is find that agile testing book. It's going to say, yep, that agile testing book looks beautiful, and it's ignoring everything else on the page, which is the unintentional blindness. But we can solve for this by just beefing up our test. You can actually mix and match these. So you don't have to do like all visual or all functional. You can have a functional assertion, which I added back on line 3 to say, make sure it's just one book. And then you can also have the visual assertion to say, okay, now that I know filter's working, let me make sure visually it looks okay. All right. Another thing you can do with this API is dynamic content. So say, for example, your application is a news site, where the structure of the page is going to be same, but you don't know what stories are going to be there. Or Twitter, for example. I used to work at Twitter, and we used this mode for the tweets because we don't know what the tweets say, but they have the same structure. You can use visual testing for dynamic content, right? There are these match levels, and these are essentially which comparison algorithm would you like to use? So there's 4 of them. The one that we were using by default was strict. There's also an exact, which does pixel to pixel, but I already told you we don't do pixel to pixel, so don't use that one. There's content that goes colorblind, so it would only verify the content and not the color. And then there's this one, layout, which uses machine learning in a different way to validate the layout of the page, not the content. So just make sure nothing is overlapping, bleeding off the edge, upside down, anything like that. But it's not necessarily going to look at the content of that. Okay. So when we run this one, notice I switched the order of the book. So in our baseline image, I had Advanced Selenium followed by Cucumber. In the next image, I have Cucumber followed by Advanced Selenium. And yet this test still passed because I used the layout algorithm. Structurally, this page looks great, right? Not worried about the content. Okay. There's some pros and cons, of course. If you care about content, this wouldn't be the best algorithm to use. Use the default strict one instead. All right. Cross-platform is also something that you can tackle with the visual testing. It opens up this whole new world. What it does is when you're ready to verify, it will take a screenshot of your application, and it basically takes the state of your application. So the DOM, the JavaScript, the CSS, all of that, and it blasts that into all of the configurations that you specify. So different browsers, different window sizes, mobile, all of that. And it puts that your application on those viewports in the state that you want it in. So it doesn't have to re-execute all of this. And all of this is done in parallel. So it makes it really, really fast. And here's how I would do that. Look on line 4 where I define this browser array, and it has these objects for each one of those, right? So I have Firefox, Chrome, and IE in different width and heights. I also say I want iPhone 10 in both landscape and portrait mode, as well as Galaxy. I don't have to touch my test. Look at my test on line 17, nice and simple, but it's going to run it across all of those configurations. And that's what it would look like. Loads all of those things up to the Applitude's dashboard, and I can see the devices that they were run on. So this gives me cross-platform testing at lightning speed. Also works for Storybook components. So if you have some components in Angular, Vue, or React, you have them in Storybook, it will test your components visually as well, which is very useful when you're sharing those across teams. All right. So there you have it. That is visual validation in a nutshell. What questions can I answer?